A mysterious visitor has just entered our solar system and is zooming through it at a crazy fast speed of 152,000 miles per hour. It's faster than anything we usually see, and it's not slowing down. How fast will it reach Earth? Will the world end when it does? Let's see. This space traveler first popped up in telescopes that watch the night sky all the time, called ATLAS. This system has eyes in Hawaii, Chile, and South Africa. They spotted the bizarre object on July 1st, and it's moving straight toward the sun at that crazy rate. What's even weirder, it's flying in a straight line, not how things usually move around here. At first, scientists thought, whoa, this thing isn't from around here, meaning it was an interstellar object, a visitor from far outside our solar system just passing through with enough speed to not get stuck by the sun's pull. Then, NASA stepped in and gave this object a name, 3I Atlas. Turns out it's most likely a comet, a big dirty snowball flying through space. You won't see it with the unaided eye or a normal telescope, but lucky for us, there's a free live stream from a powerful telescope in Italy where you can watch this mysterious traveler zoom by. We've only seen two other interstellar visitors before, one called Borisov in 2019 and the other back in 2017. You might have heard of Oumuamua before. Some thought Oumuamua might be a spaceship from another civilization, but nope, just a strange rock. Scientists think there are lots more of these cosmic visitors out there, just sneaking through without us noticing. And this newly discovered one proves it. But how exactly did it get spotted? It happened on July 1st, 2025, way out in Chile. At the time they saw it, it was about 4.5 times farther from the sun than Earth is, and it was moving fast. Unlike the planet's unusual space stuff that orbit the sun in nice, neat loops, this comet is on a hyperbolic path, meaning it's just passing through, not sticking around. Its orbit is super stretched out. This comet is tricky to size up because it's wrapped in a cloud of shiny dust, making it hard to tell how big the solid core really is. Scientists guess it's somewhere between 0.5 and 15 miles wide. The comet is going to swing closest to the sun, this point is called perihelion, on October 29, 2025, at just over 1.3 times the distance from Earth to the sun. One of the coolest things about this comet is that it likely came from the thick galactic disk, an old part of our galaxy filled with ancient stars. That means this traveler could be over 7 billion years old.
He says I'm a grumpy old man.
It's possibly packed with water ice from ancient times. In other words, it's a speedy, mysterious comet from far beyond that might hold secrets about the early universe hidden in its ice. Anyway, when scientists first noticed this comet, everyone was a bit puzzled. Was it just another asteroid or something more unusual? The path it was on looked so wild that astronomers actually thought it might come close to Earth. So it got added to a special watch list. But as more specialists checked it out, it became clear this was no ordinary space rock. This visitor was on a hyperspeed path that wasn't just around the sun. It was coming from outside our solar system. Later, it turned out that even before the July 1st discovery, this comet had already been spotted in earlier photos from the end of May and June. But no one knew what it was back then because it was hiding in the dense, star-filled area near the center of our galaxy. So it was like trying to spot a firefly in a fireworks show. At first, some astronomers thought it might just be an asteroid because it didn't seem to have that usual fuzzy glow or tail that comets have. But by July 2nd, powerful telescopes in Chile, Arizona, and Hawaii caught a faint tail and a little cloud of dust around it, the classic signs of a comet. And once they confirmed this, the comet got its official name. Lots of telescopes jumped in to get a better look. One spotted a tail stretching 15,500 miles long. That's longer than the distance from New York to Los Angeles. Others noticed that the dust around the comet had a reddish tint, just like the dust from the last interstellar comet. Scientists even tried to figure out if the comet was spinning, but couldn't tell because the dust cloud was hiding its core. The Hubble Space Telescope is going to take a look later in July, and scientists worldwide will get access to its data, so everyone can learn as much as possible about this cosmic visitor. So, the comet is going to get its closest to the Sun around October 30th, coming in to about 1.5 times the Earth-Sun distance. Right before that, it's going to swing relatively close to Mars, about 0.4 times that Earth-Sun distance away. So, Mars will get a close-up look. But don't worry, when it comes to Earth, the comet isn't coming anywhere near enough to cause any trouble. The thing is, when 3I Atlas zooms closest to the Sun, Earth will be on the other side of it. That means the comet won't get anywhere near us. Its closest pass to Earth will happen later in December, when it's already heading back out of the solar system. NASA says it won't come closer than about 1.6 times the distance between Earth and the Sun, so no worries there. Scientists are super interested in where 3I Atlas actually came from. One recent study says it probably hails from a part of our galaxy called the Thick Disk. That's where most of the stars in the Milky Way dwell. But they still don't know exactly which star sent the comet our way. One of the researchers says it could have come from tons of different stars, not just the ones nearby. That's because this comet is likely to be super old. It might have been drifting through space for billions of years before finally zooming past us. Scientists think it came inside Neptune's orbit back in 2023, and it'll pass by Neptune again as it heads back out in 2028. Depending on where you say the solar system ends, it could take decades for this visitor to fully leave our neighborhood. Now, could 3I Atlas be a spaceship sent by another civilization? The answer is almost definitely not. Back in 2017, when the first interstellar visitor Oumuamua showed up, some folks thought it would be a disguised space probe. That idea came from weird things about how it moved. They didn't quite add up. But 3I Atlas is acting like a totally normal comet. No strange moves or surprises so far. Still, some scientists are curious and want to check if 3I Atlas shows anything unusual, like tiny boosts that aren't caused by gravity. You might be wondering if we could actually visit this comet. Well, we've sent spacecraft to some space rocks before, like NASA's OSIRIS-REx mission, which landed on an asteroid called Bennu in 2020. Grabbed some samples, and brought them back to Earth. That was a big deal. People have thought about doing the same thing with other interstellar visitors, but for now, visiting 3I Atlas just isn't happening. It's a wild comet zooming through, and we don't have any missions ready or built to catch up to it. So right now, astronomers are in a bit of a race to learn as much as they can about this rare visitor before it disappears again. They've got until the end of September to study it before the sun's glare hides it from view. But then, in December, when it pops back out, they'll get another chance. Big telescopes like the Vera C. Rubin Observatory, the most powerful optical telescope out there, are ready to snap some pictures. There's even talk about using the James Webb Space Telescope, and maybe even NASA's rovers on Mars to catch a glimpse as it speeds towards the sun.
Okay, let's just say you're driving home and suddenly your GPS freezes. Your phone says you've got full bars, but it takes forever to make a call. Or maybe the call drops for no reason and you have to redial. You brush it off. Probably just your carrier being weird. But then, later, during a house party, your light flickers for a second. No need to panic, you're not haunted by a ghost. At least I hope not. No, it's much more likely that the sun is acting up. Because a giant hole about 500,000 miles wide opened in its atmosphere, and now it's sending strange stuff straight at us on Earth. Okay, so what does that even mean, a hole in the sun? Well, when we look at the sun with highly protective sunglasses, of course, all we can see is a bright, calm star. But that couldn't be further from the truth. Up close, it's total chaos. Its surface boils with magnetic storms. Loops of plasma twist and snap, and every now and then, the outer layer, called the corona, becomes unpredictable. That's what happened recently when a massive region of the Sun's atmosphere suddenly changed shape. So scientists call it a coronal hole, but don't picture a crack or a crater. It's more like an open vent in the Sun's outer layer. Our star has these invisible forces running through it, like tension lines beneath the surface. Most of the time, they loop back on themselves, but sometimes, in certain spots, they stretch outward into space like open lanes. And that's when stuff starts flying. Particles shoot out at crazy speeds in what we call the solar wind. This wind hurls through space at about 1 million miles per hour, which is fast enough to reach Earth in a few days. The area of the Sun where the wind comes from looks darker and cooler than the rest of it. That's why we call it a coronal hole. And the current one is huge, so big that you could fit about 62 Earths side by side. It stretches across a massive chunk of the Sun's southern hemisphere and is pointed straight at our planet. So, what exactly is the Sun sending our way, and what happens when it gets here? Well, solar wind isn't just fast. It's also packed with tiny charged particles the Sun hurls out when it's feeling active. And when that stream runs into Earth's magnetic field, it's like tossing a rock into a still pond. It presses against our planet's magnetic shield, distorting it like a balloon being poked from the outside. That's what creates these breathtaking auroras. However, sometimes, the Sun takes it even further. Instead of a steady stream, it blasts out a massive cloud of solar material all at once. That's called a coronal mass ejection, or CME. This can mess with GPS and jam signals, as partly because of something called the ionosphere, a charged layer way up in Earth's atmosphere that helps radio signals travel. When that layer gets disturbed, signals start bouncing weirdly or dropping out completely. In late May 2025, Earth was hit by a geomagnetic storm. It was classified as a G3, which means strong. It came from a stream of high-speed solar wind released by a coronal hole and caused visible auroras as far south as Iowa and Oregon. Warnings issued pointed to GPS and shortwave radio disruptions during the storm, but no serious issues were reported. Just a few days later, the situation got worse. On June 1st and 2nd, another storm happened. This time, it was a G4 class. That one is considered a severe level event, just one step below the highest category. The skies lit up. People across the northern U.S., and even as far south as California and New Mexico, saw glowing curtains of green and pink across the night sky. It's the kind of thing you normally have to travel to the Arctic or Antarctic Circle to see. Okay, fine, I'm convinced. Ghosts don't do this stuff. But it wasn't just a light show, although even astronauts aboard the International Space Station were able to capture breathtaking pictures. Airlines received radiation warnings and may have altered some flight paths as a precaution. Satellite operators were monitoring for signal drift, and high-frequency radio used by ships, planes, and amateur operators could have experienced brief disruptions. But then came another one. A few weeks later, in mid-June, Earth was hit by a G2-class geomagnetic storm. It wasn't as intense as the earlier G4 event, which meant less risk for disruptions and another chance to catch glowing skies on camera. Then, just to keep things interesting, the Sun followed it up with a pair of powerful solar flares on June 17th and 19th. Solar flares are distinct kinds of outbursts, but with similar consequences. The Sun's surface is constantly moving, dragging magnetic fields around like tangled cords. Eventually, those lines get twisted so tightly that they snap, and that snap is what causes a solar flare. If a CME is the Sun launching materials, a solar flare is more like the Sun flipping a light switch, except the light is radiation, which floods space at the speed of, well, light. Flares hit fast, sometimes within minutes, and they don't need to carry particles to cause problems. So, while CMEs are like massive clouds of solar blasts that take a day or two to arrive, solar flares are the flash that hits you before you even see it coming. And in mid-June, Earth got hit with 2 of them, one after another. The second one was the stronger one and briefly knocked out radio communications across parts of the U.S. Why is all this happening? It's not random. The sun follows a pattern. It goes through phases, kind of like moods. Yeah, solar moods. Every 11 years or so, it gets a little dramatic. More flares, more sunspots, more weirdness. Scientists call this peak period the solar maximum, and we are currently in the middle of one. Right now, we're in solar cycle 25, which is expected to peak sometime between now and early 2026. During this time, the sun's getting active. It seems like things are just starting to heat up, and we can expect even wilder storms in the coming months. But if that's the case, should we be worried? Well, not really. At least not in a run for the bunkers kind of way. Solar storms don't hurt people directly. You're not going to get sunburned through your roof or microwaved in your sleep. Unless they announce a beautiful aurora, you won't even know it happened. The bigger concern is for the systems quietly running in the background: satellites, navigation networks, and electricity. When the magnetic field gets disturbed, it can cause electric currents to form on the ground. And those currents don't just stay underground, they can sneak into power lines. If those currents get strong enough, they can overload transformers, damage electrical systems, and even knock out entire power grids. That's what happened in Quebec in 1989, when a solar storm blacked out the whole province in 90 seconds. So that's why agencies like NASA and NOAA track solar activity constantly. They know when something's headed our way, how strong it might be, and what kind of warnings to send out. Now, we usually don't think about the sun unless it's too hot or messing with our beach plans, huh? Or when it's freezing and we're stuck indoors, dreaming of summer. But occasionally, it reminds us that it's still a wild thing. A fascinating ball of chaos. It flares, it erupts, it throws giant waves of charged particles across space just to see what happens. And even from 93 million miles away, we feel it. A dropped signal, a beautiful glowing sky, a power flicker. Little hints that we're not as disconnected from space as we'd like to believe. So, the next time your GPS acts weird or your screen glitches for no reason, don't blame your phone or Casper. It just might be the sun feeling moody again.
What the? Look! Do you see this? Part of the sun has broken off, and it's now churning above the star's surface, having formed a giant vortex. What's going on there? Well, let's admit it. We still know very little about the sun, however crucial this star is for our well-being. But in the case of the broken sun, scientists can probably explain what happened. Some of the star's plasma likely erupted from the sun's surface and broke away, creating something resembling a crown-like vortex over the solar North Pole. And still, this is just a theory. Astronomers need to conduct further analysis to figure out if this is what really happened. At the moment, they're a bit baffled, since this phenomenon is nothing like anything they've seen before. But the footage we've got is undeniably impressive. What is more alarming, though, is that the behavior of our star is currently changing. The sun is ramping up its activity. It's getting rowdier with flares and sunspots. This year, it's flared every day so far. It's also thrown up a few X-class and M-class flares in January of 2023. These flares are the largest and second largest eruptions our star can produce. Even though it sounds kind of alarming, don't worry. The sun has certain activity cycles that repeat every 11 years or so. Some of them are relatively calm, while others are absolutely wild. These cycles happen simultaneously with the fluctuations in the sun's magnetic field. When it gets the weakest at the star's poles, they switch places. This makes the polarity of the magnetic field reverse. This is the very period of time when the sun is the most active. It's known as solar maximum. Right now, we are near this solar maximum, Scientists can figure it out by analyzing unusual solar activity. But since the sun is still pretty much a mystery to us, no one can determine when the polarity reversal is likely to occur. A rough estimation is July of 2025. At the same time, we can't say that the current solar situation is normal. It's true that each sun's cycle is different from others. Some are weaker and some are more powerful. So this one, which started in December of 2019, has already significantly exceeded all scientists' expectations and keeps doing so. Which brings us back to the vortex observed on February 2nd, 2023 that impressed astronomers so much. It started as a solar prominence. This is a bright plasma filament extending away from the surface of the sun. And, let me tell you, solar prominences are an absolutely regular phenomenon. And like the most recent one, they often occur at high altitudes around the sun's crown, which is the outermost layer of the star's atmosphere, also known as the corona. Anyway, prominences like the one in question are called hedgerow prominences because they look like a hedge. But what surprised astronomers happened a bit later. The material of the filament apparently broke away and started circling the pole near where it occurred at 60 degrees latitude and at a speed of about 60 miles per second. And it lasted for about 8 hours. One scientist, who has been observing the sun's cycles for decades, claims that he has never seen vortices like that. Unfortunately, solar poles are very difficult to observe, so it might be a while till we get our answers. For the first time, a spacecraft touched the surface of the sun in 2021. It was NASA's Parker Solar Probe that flew through our star's upper atmosphere. It also took some samples of particles and examined magnetic fields there. It was a real milestone and a giant leap for solar science. Getting their hands on the very stuff the sun is made of will allow researchers to uncover crucial information about our star and its influence on us and the entire solar system. The Parker Solar Probe moved closer to the sun's surface and started making discoveries that other spacecraft were too far away to see. For example, the probe examined the solar wind from within. It's a flow of particles coming from the sun. These particles can influence us here on Earth. Even before coming super close to the star, the Parker probe found out that near the sun, there were loads of magnetic zigzag structures in the solar wind called switchbacks. But at that time, scientists couldn't figure out how they formed and where they appeared. But now, more than 2 years later, we know for sure that switchbacks originate at the solar surface. As you know, the sun doesn't have any solid surface, unlike our planet, but it has a superheated atmosphere, which is made of solar material bound by magnetic forces and gravity. When pressure and rising heat push that material away from the star, it eventually reaches a point where the sun's magnetic field and its gravity can't contain it anymore. This point has its own name, the Alphane critical surface. It marks the edge of the solar atmosphere, and that's also where the solar wind begins. The material that manages to make it past the boundary turns into the solar wind. It drags the sun's magnetic field toward Earth and beyond. But the most important thing is that past the boundary, this wind starts moving so fast that its waves can't return back to the sun, which literally means severing all connections with the star. During its flyby, the Parker probe passed inside and out of the sun's corona several times, which proved that the Alphane critical surface wasn't shaped like a smooth sphere. It has valleys and spikes, and its surface is kinda wrinkled. At one point, the probe even came across a pseudo-streamer. These are massive structures in the sun's corona that rise high above the surface of the star. You can see them from Earth during solar eclipses. And you know what? For the Parker probe, passing through the pseudo-streamer was like flying into the eye of a storm. Inside, everything was much quieter. Particles moved more slowly, and there were fewer switchbacks. It was a huge change from the barrage of particles the probe encountered inside the solar wind. Now, speaking of solar flares, those are pretty dangerous for Earth. The radiation they release can interfere with our radio communication. Such storms affect all electronic systems, from the internet to power grids, and can even destroy satellites. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares that people should be worried about. They cause the strongest and longest-lasting solar storms. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. A powerful solar storm could cost people $1 trillion to $2 trillion. Luckily, if such a powerful solar storm was heading our way, we'd most likely get some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. It would give us some time to prepare, between several hours and a couple of days. And if transformers were taken offline in time, the consequences wouldn't be so dramatic.
A solar storm is crashing into Earth like a cosmic tsunami. First, the atmosphere ignites, sparking massive auroras. High-energy radiation slams into the surface, frying power grids, turning lights off across continents, and knocking out satellites. Planes lose navigation, radios go silent, GPS systems crash, radiation levels spike dangerously. Communication collapses, emergency services scramble in the darkness, and chaos spreads as people struggle to cope. Solar particles start to strip away the very air we breathe, slowly peeling off our atmosphere. Soon, Earth will become a harsh and hostile place. That's what solar activity can do to our planet and its inhabitants if we didn't have a protective shield called the magnetosphere. But even with this barrier, we're still in for serious problems. A mysterious 100-year solar cycle may have just restarted, and it could mean decades of dangerous space weather. New research suggests that the unexpected intensity of the ongoing solar maximum may be partly tied to a lesser-known 100-year solar cycle. If the sun is indeed entering its villain arc, solar activity could spike even further in the coming decades. It means more solar flares, more chances of them messing with satellites, and way more of those crazy northern lights people keep posting on Instagram. Sure, not everyone's buying it. Some space nerds want more proof before jumping on this solar hype train. Let's break it all down into detail first. The sun goes through a kind of mood swing every 11 years. This is called the solar cycle. It starts off at a solar minimum, which is pretty chill, then slowly gets rowdy. We're talking sunspots, solar flares, and other fiery drama. Once we reach solar maximum, the situation starts to calm down again. The sun gets sunspots, dark patches on its surface, like the freckles we humans have, when its magnetic field starts flipping out. Literally. The sun's magnetic field completely flips during peak solar drama. Scientists track how many of these spots show up to measure how spicy the sun is getting. But wait, plot twist, there are other cycles too, like the Hale cycle, which occurs around every 22 years. This cycle controls how magnetic fields move across the sun. Plus, way back in history, there were moments when the sun basically went on Do Not Disturb mode. During the Maunder minimum, our star was basically in sleep mode for 70 years. In other words, the sun might be entering a new extra phase, and things could get dramatic. On the bright side, that means more auroras. At the same time, it could also cause issues for satellites, GPS, and other stuff we rely on. Ugh, let's just hope it doesn't mess with YouTube. This extra phase is called the Centennial Gleissberg cycle. It's basically the sun's once every 100 years I do something weird moment. Scientists think it messes with how intense sunspot cycles get. No one has fully worked out how this cycle works yet, but some low-key sloshing of magnetic fields inside the sun might be causing it. Yep, I did say sloshing, like a giant cosmic smoothie. A recent study from March 2025 claims that the CGC might have just hit restart. That could explain why this current solar maximum, the sun's drama phase that started in early 2024, is being so weird and unpredictable. How did researchers figure this out? They looked at something called proton flux. Basically, it's how many positively charged particles are flying around in Earth's radiation belt. There are 2 of these belts, shaped like donuts that wrap around Earth, full of particles from the sun. The thing is, when the sun is active, our upper atmosphere swells, which makes the inner radiation belt lose some of those protons. And when the sun is chill, proton numbers go up again. So those protons have been increasing for like 20 years, but just started to drop in the past year. Which basically screams, CGC has just hit minimum. Time for the sun to crank it back up. The data came from NOAA satellites that flew through the South Atlantic Anomaly, which is like the Bermuda Triangle of space. It's this bizarre zone over South America where Earth's magnetic field is weaker and space radiation gets closer to Earth. This area is perfect for observing proton activity without sending a satellite into the actual danger zone. So, right now, we're probably nearing the end of the sun's current chaos phase, aka the peak of solar cycle 25. Back in May 2024, it hit us with one of the craziest geomagnetic storms in 500 years or so. And yes, that means super bright auroras lighting up skies all over the world, even in places that usually only get clouds and vibes. But the scariest thing? This wasn't supposed to happen. During the last cycle, the sun was oddly calm. So NASA and NOAA looked at that and thought that the next solar cycle would probably be the same. No biggie. Well, they were wrong. And they even admitted it. Now, scientists think that SC24's quiet phase was because of the Centennial Gleissberg cycle being at its low point. That probably made it the quietest sunspot cycle in 100 years. So now that SC25 is lit again, pretty literally, it might just mean the sun is back to doing what it normally does, being a little chaotic and wild. Recent studies think the CGC minimum is finally over. That would explain why the current solar activity is turning up the heat, and why the last one felt like a cosmic snooze. An even cooler thing is that a 2024 study used AI to analyze sunspot patterns and found that CGC might be messing with our forecasts more than we thought. And if this long-term mood swing of our star is really back on the rise, future solar cycles could be just as wild as the one we're in now, or even wilder. After all, we've just passed the CGC's low-energy mode, and we won't hit the next maximum for another 40 to 50 years, around solar cycle 28. That's a few decades away, but the sun's already throwing tantrums. The scariest part is that future solar activity might be twice as intense as what we're seeing now. You might be wondering right now, why should I care? Well, because when the sun freaks out, it messes with our stuff, especially in space. Satellites get dragged out of orbit because Earth's upper atmosphere literally puffs up like a marshmallow in a microwave when solar activity spikes. And this has already happened to a few spacecraft recently. And with tons of private satellite mega constellations like Starlink and its squad, the risk goes way up. There are some, even though those are few, that might not be ready for a full-blown sun rage event. Time to wear SPF 100 for your satellites. Astronauts are also at risk. More solar flares mean more radiation and more danger for humans in orbit. At the same time, more space tourists and missions mean more people potentially in the sun's cosmic splash zone. At the same time, not everyone is buying into the whole CGC is back and ready to party theory. Some experts say it's a cool theory, but we shouldn't get carried away. The thing is, the proton flux, those space particles we've been watching, only started dropping last year. That's not a lot of time. It might just be a short-term dip, like the sun sneezed and now everyone's freaking out. Also, we've only been able to track this stuff properly for 30 to 40 years or so, which is basically nothing in sun time. So there's no solid before and after data to compare CGC cycles and say, yep, this is definitely a pattern. Plus, the CGC itself is kinda mysterious. Like no one can fully agree on what it even is, how it works, or how much it actually messes with sunspot cycles. It's like the Bigfoot of solar science, blurry, weird, and causing drama in group chats. But even skeptics admit that the new study is interesting and well-intentioned, and that it might help us predict future solar cycles better. We just need more time, more data, and better definition of the CGC before we treat it like the ultimate weather app for the sun. NASA sent a spacecraft right into the sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was canceled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend one lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. Sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you. but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus the strongest ones, X-class flares, have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.